Example number 1, we're using the chain rule. We're going to find f prime of x if f of x is equal to the square root of x squared plus 1. So we're going to do this in two different ways. The first way here on the left is by using definition number 2. That means we're using the composite function, which is f composite g prime of x, which is equal to f prime of g of x times g prime of x. Okay, so we first need to identify, okay, what is the outside function? So we're going to let the outside function represent f of u, which is going to equal the square root of u. And we're going to let g of x represent the inside function, which is x squared plus 1. So now, if we want to find the derivative of the function f of u, well then that's going to be 1/2 times u to the negative 1/2. And then if we want to write this as a radical and with non-negative exponents, it's going to be 1 over 2 times the square root of u. Okay, now when we want to find g prime of x, we know that g prime of x, well, the derivative of x squared is 2x, and the derivative of 1 is going to give us 0. Okay, so now if we use that formula, we want to find f prime of x. Well, that's going to equal f prime of g of x times g prime of x. So what that means here is that g of x is going to be the input on f prime. So that means that we have 1 over 2 times the square root of what g of x is. Well, let's take a look at what g of x is. Well, g of x represents x squared plus 1. So we're going to replace this u now to be x squared plus 1. And then what we're going to do is we're going to multiply that by g prime of x, which we know is 2x, and that's 2x divided by 1. So again, where do we get the 2x from? Because g prime of x is equal to 2x. Okay, so now we have this in our numerator. So we know that we have 2x over 2 times the square root of x squared plus 1. And so we know that we end up with x divided by the square root of x squared plus 1. And so therefore f prime of x is equal to the following. Okay, and again, that's because we can simplify the 2's here. Okay, so that's the first solution. Okay, now if we want to then look at equation number 3, which is dy over dx, which is equal to dy over du times du over dx. So let's go ahead and let's talk about our first step here. Okay, so what we're going to do is we're going to let u represent x squared plus 1. Okay, and we're going to say that y is going to equal the square root of u. So what does that mean? Well, we know that our f prime of x is going to equal dy over du times du over dx. So what does that mean? Well, what does du or dy over du equal? Well, dy over du of the square root of u. Okay, well that means that the derivative with respect to u is going to be 1/2 u to the negative 1/2, which is equal to 1 over 2 times the square root of u. Okay, and then when we find du over dx of x squared plus 1, then we're going to get 2x. So, as we stated up here, if we want to use that formula, f prime of x, well, what do we know about du over dy? Well, dy over dy over du is equal to 1 over 2 times the square root of u. So we have 1 times 2 times the square root of u. Well, what do we let u equal? We know that we let u equal x squared plus 1 times du over dx. Well, if you notice here, du over dx gave us 2x. So therefore, we multiply this by 2x over 1. So we're going to get f prime of x, which is equal to 2x over 2 times the square root of x plus 1. And so therefore the derivative is going to give us the same thing we got in the first part, which is x divided by the square root of x plus 1. Okay, so let's take a look here. So it's saying here, so when we use, so up here, when we're using formula 3, we should bear in mind that dy over dx refers to the derivative of y when y is considered as a function of x, called the derivative of y with respect to x. Whereas dy divided by du refers to the derivative of y when considered as a function of u, which is the derivative of y with respect to u. So for instance, in example 1, y can be considered as a function of x and also as a function of u. Now let's make a note. Now, in choosing the chain rule, we work from the outside to the inside. So formula 2 says that we differentiate the outer function f at the inner function g of x, and then we multiply by the derivative of the inner function. So this is what we're saying here. We have d over dx, so the derivative with respect to x. The outer function f is the outer function, evaluated at the inner function, which is g of x, is equal to the derivative of the outer function f prime of the evaluated at inner function g of x times the derivative of the inner function.